Okay, let me try this again. How to write an equation for a graph. Take number 3 or 4 or 5. Fortunately, I checked on YouTube and only 3 of you have seen the original video, which was A, overly complicated, and B, wrong. Sorry. Jeez. Wish we had graphing calculators to check. But here we go. Attempt number whatever. Clearly tangent, and we know that tangent, or you need to know, sine over cosine, blah blah blah. Yeah. I'm gonna try to make this a little bit less complicated. Dun dun dun. Yeah, I'm gonna totally break it down. Now that you've tried, hopefully tried. The other important thing about tangent and cotangent, super important, is that a normal period, like if we were just graphing y equals tangent of theta, a normal period is only 180 degrees, totally unlike sine, cosine, secant, cosecant. So that is definitely going to be critical in doing these type of problems. And here we go. So we know the sinusoidal axis is 5. Not hard. We know the amplitude is 2. Not hard. We know it's a tangent function. Not hard. So it's the stinking frequency where I was messing up. And right there. Another case in point. Remember way back when we first started sinusoidal functions, the definition of a period is basically when does this point repeat itself. So let's pretend that that's the first time it happens, and the next time it happens is over here. So first time it happens is at, I'm going to call that -10. Second time it happens is at +20. So the period for this function, that's from here to here is one cycle, one period, that's 30 degrees. So from -10 to +20, 30 degrees. Period is 30 degrees. Because normal period is 180, obviously there's some sort of horizontal dilation taking place. And then frequency. Okay, pay attention. Andy, pay attention. So normally it's 360 divided by the period. But for tangent and cotangent, it's 180 divided by period. Sometimes 180 divided by 30 is 6. I think in the original video, I think I told you guys 12 because I'm an idiot. But I checked on a calculator. Okay, so that's hard part number 1, finding the frequency. Hard part number 2 is the phase displacement. But I'm gonna break it down real easy for you. Ready? For tangent only, not for cotangent. For tangent, you can use any of these middle points as your phase displacement. So I could have +40. Yeah, that's one correct answer. I could have I'm gonna write the whole thing all over. 5 + 2 tangent 6 theta minus. I could use +10. That's another acceptable answer, and then another acceptable answer is -20. Voila. There. 3 acceptable answers. Cotangent. That's when it goes this way. Yeah. Cotangent is a little bit harder. And if you probably bad teaching on my point. We didn't even need to know that tangent was sine over cosine. You need to know that to graph it for sure, but writing the equation, if you just kind of just taught you a faster way to do it, I suppose. Anyways, cotangent is cosine over sine, blah blah blah. Do we really need to know that? No, I'm going to show you a much faster way to do it. Dun, 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 period. Well, let's start with the easy stuff. Sinusoidal axis 3, amplitude 7. It's a cotangent problem. Period. Period is from here to here. So 40 to 100, that's 60 degrees. It is tangent, cotangent, so you're going to use 180, not 360. 180 divided by period. So 180 divided by 60 is 3. I think in the original video I told you 6 because I'm an idiot. Voila. However, I'm showing you the faster way to do it. We need the vertical asymptotes. When you're doing cotangent, the phase displacement will be the location of the vertical asymptotes. So, there's a vertical asymptote here. There's a vertical asymptote here. There's a vertical asymptote here. So, minus 10, that's acceptable. Minus 70, that's acceptable. And minus 130, also acceptable. So, recap. 180, not 360. Phase displacement for cotangent. Look, are wherever the vertical asymptotes are. Dun, dun, dun. But for tangent, the phase displacements are wherever the middle points are. There we go. So middle point. Dun. Why? Because you're really writing you need a cosine phase displacement. So this is at negative 40. So is that. You could use this. This is at negative 10. So is that. This is at positive 20. So is that. So you can use the middle of the road points as your phase displacement. Yeah? That was way better, huh? See? I know what I'm doing. Maybe on the fourth try sometimes.